thing is, okay, where in real life are we going to have 3 equations and 3 unknowns and all that kind of stuff? Well, when there's a lot of stuff happening in real life. Okay, so let's read this problem. It says, there's a natural fibers clothing that charges $4 for shipping on orders of $25 or less, $8 for orders that are range between like $25 and $75, and then $10 for shipping for any orders over $75. 1 week, the shipping charges for 600 orders totaled $4,280. And then the one last bit of information that they told us is there were 80 more orders for the $25 or less than those that were more than 75. So there's a lot going on. So the first thing I'm going to do is I'm going to label my variables, X, Y, and Z. So do you guys realize that there's 3 different charges for shipping? That's going to be our X, Y, and Z, okay? So 25 or less will be our X. That 2501 to 75 will be our Y. And then over 75 will be our Z, okay? And I know it doesn't look it, but they actually gave us enough information to write 3 equations using X, Y, and Z, okay? Let's start with the most basic. How many total orders were there? 600. So how do you find a total? That means all the ones that were 25 or less, X, plus all the ones that were 25 to 75, Y, plus all the ones that were 75 or more, Z, all those totaled $600. So how do we show that as an equation? X plus Y plus Z. These represent the different tiers of our orders, right? But X plus Y plus Z represents all the orders. Now, the next part of information is in that same sentence, right? So instead of thinking about total orders, you can think about total amount charged for shipping. Well, all we have to do is kind of the same equation. We have X, Y, and Z happening. But instead of it totaling 600 orders, we have a total amount that was charged, right? So we know the right-hand side is going to be 4,280, but how do we figure out X, Y, and Z? Well, just the coefficients, guys, are just going to be the price per charge, right? So how much were they charging for shipping for the $25 or less? So we'll just have $4 for every X, $25 or less shipping, right? How are we going to do Y? $8. 8Y. And then how are we going to do Z? 10Z. And what did we say the total shipping was? 4,280. Okay? So notice we had one equation was just simply how many total orders did we look at? And then one equation was, okay, each of those orders were multiplied by $4, $8, or $10 in shipping. That gave us a total shipping amount. Okay, so the last sentence, it gets kind of tricky. There were 80 more orders for 25 or less than the more than 75. So they're talking about just X and Z, okay? So the 25 or less was X, right? Were shipped then the orders for more than 75, that was Z. So that means Z equals, or excuse me, that's right. So which one had more? X. So X equals, I'm trying to think the easiest way to explain it to you, sorry. So it says 80 more orders of 25 or less. So there's more X's than there were Z's. So Z equals, or Z plus 80 equals our X. I should write it that way, sorry. I know it's a little backwards. Who had more? The X, right? It said 80 more of those. So if he had more, that means we had to add 80 more just to set them even to each other. So what's another way we can write this? I can just rewrite this with X over here, but he'd be a negative X, right? Do you agree? Like if I moved him over? So, and then move the 80 over. So really this is negative X plus Z equals negative 80. That's just another way to write him. All right. It doesn't matter who we choose first. We just choose somebody that we can see an obvious cancellation going on. Notice the first one would be perfect for x, y, or z. It doesn't really matter. So who do we want to get rid of first? It doesn't really matter.
Z.
You want to get rid of z first?
Yeah.
Okay. So if we're going to get rid of z first, I would take maybe the first two and multiply the first one by a negative 10. And that would cancel out with that. Okay. So number one, let's take equation 1 times negative 10 and see what we get. Okay? So we'll have negative 10x minus 10y minus 10z equals negative 6,000. And who are we going to combine him with? Just equation 2. 4x plus 8y plus 10z equals 4280. Now, I did not do it this way in my notes, so I want you to know that's okay. How you choose to approach it, how you choose to cancel out, there's multiple ways. I'm just pointing that out because I'm going to actually have to calculate this. Okay, so who's going to cancel our z's? That's what we decided. Negative 10x plus 4x gives you a negative 6x. Negative 10 plus 8 gives you a negative 2y. And these together, negative 6,000, somebody double check my work, plus 4280 gets us negative 1720. Okay, so since we had z cancel with those two, we're going to have z cancel with the other two. So let's pick equation 1 and equation 3 and just multiply one or the other by a negative, right? Because the z's, their coefficients match, but they don't have opposite signs, okay? So, what'd you say?
Wouldn't be 6. You'd multiply by 6.
Nope, because I want z to disappear again, okay?
Oh.
I want z to disappear, so I'm going to pick equation 1 and equation 3, and I need the z's to cancel. They have the same coefficients, they just need opposite signs, so it doesn't really matter which one I choose. So step number 2, let's take equation 1 as is. X plus y plus z equals 600. And let's take equation 2 times negative 1, or equation 3 times negative 1. Positive x, negative z equals positive 80.
So the x's would cancel.
And so you have,
Z's would cancel, so y equals.
well, the x's don't cancel. We should add them together, right? So we'll have
Oh, never mind.
2x plus y equals 680.
Just kidding.
But what we've done, guys, is we've taken 3 variables and narrowed it down to 2 variables. So once you do that, then you always grab those 2 together and decide who you want to cancel. To me, the y is the obvious choice since he's singular. So I'm just going to take this equation times 2 to make him cancel out. And again, I know there's not a whole lot of good ways of doing this. So this is going to be times 2 for step number 3. Negative 6x minus 2y equals negative 1720. And then I double this, so this will be 4x plus 2y equals, let me do that real quick, 680 times 2, so 1360. Oh, I'm off the chart, sorry. And what do you notice? We got it down to x, right? So the y's will cancel and we're left with negative 2x equals negative 360. By negative 2, so x equals 180. I'm going to star that because that's one of our answers. What does that mean? It means how many orders of $25 or less do we have? 180 orders, so keep that in mind. All right, now that's the easy part, right? We'll just work backwards, grab one of those 2 equations we just used, and plug in 180 for x. So I'm just going to use this one right here, okay? So step number 4 is we're going to solve for y. Because we can plug x in, right? So we have 2x plus y equals 680. But I know what my x is. So we have 2 times 180 plus y equals my 680. So you double your 180, you should get, what is that, 360, I believe. So 360 plus y equals 680. And I just got to do what to solve for y?
Divide.
Not divide.
Wait, subtract.
Just subtract them over. So you should get 320. So what does that mean? It means we had 320 orders that were between that $25, $75 range. All right, then you go back to the originals, X, Y, any of these three, just pick him because he's easy, right? Because you have X, so we can solve for Z pretty easily. So step number five, we're going to solve for Z. I'm going to use my original equation, negative X plus Z equals negative 80. You could have used any of the three, okay? So negative 180 plus Z equals negative 80. Since he's a negative 180, I'm just going to add him over. So Z equals 100. So how they want it, I think this is one case where they don't want it like as a triplet. You know, I know, and you can. Let's write that. We can if you want. 180, 320, 100. I think what they have is they have it kind of like what we did up here is like how many of each order do you have, you know. So 25 or less, we had 180 orders. 25.01 to $75, we had 320 orders. And then over 75, 100 orders. Okay.
That's not terrible.
It really is not terrible. The thing is, like I said, I don't think you'd appreciate or understand tomorrow's lesson without seeing what technically our calculator is doing for us. Does that make sense? Like, what we're doing with all these elimination methods, our calculator is programmed to do that. And so when I do it, if I don't teach this, it just seems like it's magic. And I'm just saying, no, someone's programming it to do exactly what we just did today.
Let's do more.